Welcome to this video series where we create a Lisp parser from scratch with TypeScript. So far in the series, we've created a lexer that can parse atoms and lists. Then we extended that with an evaluator that can handle arithmetic expressions. And in the last episode, we extended the evaluator to handle logical, boolean, and conditional expressions. In this episode, we will extend it further so that it can handle user-defined functions and execute them, including recursion. The schema of a function definition in Lisp looks like this. We begin by define operator, which requires a function name, a list of parameters, and one or more expressions that forms the body of the function. As always, we start with a test. The implementation is very much like what we did before for arithmetic and conditional operators. Create a function that will handle these operations and extract the items that we require to get the job done. Missing closing bracket is giving us a bit of grief here. Okay, now I'm gonna go ahead and quickly complete the set of tests to cover malformed function definition criteria. In order for us to refer to this function and execute, we need to store this function in a context. So let's define that. This is very similar to what we did before for arithmetic operators. Now that we have a context, it needs to be passed around. It's a good idea to check if a function definition already exists. If so, we throw an error. We use the function name symbol as the key and set a lambda to it. Inside the lambda, we have the code to bind arguments to parameters. As per the specification, we extract and evaluate all bodies and return the result of the last one. Now our main function is a special one. We will encapsulate all the user-defined code inside that. Since it is a special function, we will automatically execute it. And here's a test for it. We should create a function called run to implement that functionality. Okay, great. We can run the main function. Here's another test to see if it can evaluate an expression and return the result. Now we're going to go up a notch to include a nested function inside the main. This test fails with returning fn, which is encouraging. This means it found a symbol but doesn't know what to do with it. This is because we haven't yet implemented the perform function. It is quite similar to the run function we just created. Now that it is done, let's pass in an argument to a function. As expected, this test fails. This is because the symbol n can't be resolved yet. So let's implement the symbol resolution. Now you may have noticed that we should have a way of representing literal strings that doesn't need resolving. Standard way of specifying a literal string in Lisp is to use a single quote in front of the symbol name. Let's handle that case. This test captures that scenario. Parameters are what you specify when you define a function. They are symbols. Arguments are what you pass into that function. They are values. And your function implementation would be manipulating symbols and says how to produce a value to return. And now for the grand finale, to create a recursive function and execute it. What better way than to create a factorial function? Let's try out a few values. Factorial 5 should be 120. Let's try another one. Factorial 6 should be 720. What about factorial 20? Let's ask Google. It is this humongous number. Yes, it works. So this concludes the Lisp Interpreter series. The implementation is not complete, but we have all the major parts of the language implemented. It can be extended in many ways. If you'd like me to try something interesting, please leave a comment below. I may use this in future videos, especially in generative art projects, just for fun. Thanks for watching. If you like what I create, please support the channel by subscribing.